everyone, in the previous video, I discussed our double angle identities. This time, we're going to deal with half-angle identities. Similar to the double angle identities, I won't be discussing the derivation part. I'll focus on how we can use these identities to solve problems. The half-angle identities are as follows. Sine of 1/2 u equals positive or negative square root of the quantity 1 minus cosine u all over 2. Cosine of 1/2 u is equal to positive or negative square root of 1 plus cosine u all over 2. And tangent of 1/2 u is equal to plus or minus the square root of the quantity 1 minus cosine u all over 1 plus cosine u. So where do we really want to use these half-angle identities? Well, basically, it's like we don't know what sine of 15 degrees is, but we do know sine of 30 degrees. Since 15 is half of 30, there must be a way for us to get to sine 15 degrees from sine of 30 degrees. What is that way? That's to use our sine of the half-angle identity. So let's see how we can do that. Let's say we want to find sine of 15 degrees, cosine 15 degrees, and tangent 15 degrees. Let's do them one by one. Let's do sine of 15 degrees first. So we know that 15 degrees is half of 30 degrees. So we know that u is equal to 30 degrees. So let's go back to our formula, which is sine of 1/2 u equals positive or negative square root of 1 minus cosine u all over 2. How do we know whether we'll use positive or negative in our formula? Well, the key is to look at the quadrant where our angle of 15 degrees is. We know that it is in quadrant 1, so its sign value must be positive. Thus, sine of 15 degrees is equal to the positive square root of 1 minus cosine of 30 degrees all over 2. We now plug in the value of cosine 30 degrees, which is square root of 3 over 2, so we have the square root of the quantity 1 minus square root of 3 over 2 all over 2. We proceed to do the operation, so we have sine of 15 degrees equals the square root of the quantity 2 minus square root of 3 all over 2 over 2. Equals, you have the square root of 2 minus square root of 3 over 2 all over 2 times the reciprocal of 2, which is 1/2. And finally, you get sine of 15 degrees equals 2 minus square root of 3 all over 4. Since 4 is a perfect square, we are left with the square root of 2 minus square root of 3 all over 2. We also want to find cosine of 15 degrees. So we still use the fact that 15 degrees is half of 30 degrees. If you notice, the formula is actually almost the same of sine of 1/2 u, only that the operation now between 1 and cosine u is addition. So we do the same and change it to addition. So we have cosine of 15 degrees equals the square root of the quantity 1 plus cosine of 30 degrees all over 2. When we plug in the value of cosine 30 degrees, we have the square root of the quantity 1 plus square root of 3 over 2 all over 2. When we simplify, we have cosine of 15 degrees equals the square root of 2 plus square root of 3 all over 2 all over 2. And then, of course, you multiply the reciprocal of 2, so you have the square root of the quantity 2 plus square root of 3 over 2 times 1/2. Finally, we have cosine 15 degrees equals the square root of 2 plus square root of 3 all over 4. And since 4 is a perfect square, we take the square root of it, so you have the square root of 2 plus square root of 3 all over 2. Lastly, we're doing tangent of 15 degrees. Since we know that tangent is the ratio of sine to cosine, we can choose to use the formula or just get the ratio of the values that we got for sine of 15 degrees and cosine of 15 degrees. Now we have tangent of 15 degrees equals the sine 15 degrees, which we obtained earlier, so that is the square root of the quantity 2 minus square root of 3 all over 2, all over the cosine of 15 degrees, which is the square root of 2 plus square root of 3 all over 2. We simplify that and we get tangent of 15 degrees equals the square root of the quantity 2 minus square root of 3 all over 2 plus square root of 3. Let's have another problem. Let's say we are given triangle ABC with angle theta. Side AB, the opposite side of theta, measures 4 units, while AC, the hypotenuse, measures 5 units. Now we're going to find sine of theta over 2, cosine theta over 2, and tangent theta over 2. Now, if we go back to our formulas, you will see that we actually need to find cosine theta. Cosine theta. To do that, we need to remember our ka in SOHCAHTOA. We know that cosine theta is equal to the ratio of the adjacent side over the hypotenuse. We know the hypotenuse, but we don't know the measure of the adjacent side yet. However, we know that we can easily find that out using our Pythagorean formula. We know that a squared plus 4 squared is equal to 5 squared, and therefore a is equal to 3. Now that we know that the adjacent side measures 3, then we know that the cosine of theta is equal to 3 over 5. Now we can solve for sine theta over 2. So again, in the formula, we know that sine of 1/2 u equals plus or minus the square root of 1 minus cosine u all over 2. But we're only going to take the positive because we are given here a triangle. So we have sine of theta over 2 equals the square root of 1 minus the cosine of theta, which is 3 over 5, all over 2. We simplify that, so you have sine of theta over 2 equals 2 over 5 all over 2, the square root of that quantity. And therefore, you get sine of theta over 2 equals the square root of 2 over 5 times the reciprocal of 2, which is 1/2. So you're left with 1 over 5, the square root of 1 over 5. And when we rationalize that, we have the square root of 5 over 5. We also solve for cosine of theta over 2. So cosine of 1/2 u, remember, is equal to the positive or negative square root of 1 plus cosine u all over 2, but we're only taking the positive. So you have cosine of theta over 2, therefore, is equal to the square root of 1 plus cosine of theta, which is 3 over 5 all over 2. We simplify, so we get cosine of theta over 2 equals the square root of 8 over 5 all over 2. We multiply 8 over 5 by the reciprocal of 2, which is 1/2. So you have cosine of theta over 2 equals the square root of 8 over 5 times 1/2, which will now give us the square root of 4 over 5. And as we know, square root of 4 is 2, so you have 2 over square root of 5, but we need to rationalize that, so you have 2 square root of 5 all over 5. Lastly, we will solve for tangent of theta over 2. We have this formula, or we can also just get the ratio of sine of theta over 2 to cosine theta over 2, since we've previously obtained the values for these. So we have tangent of theta over 2 equals the square root of 5 over 5 all over 2 square root of 5 over 5. By canceling out some quantities, you will only be left with this tangent of theta over 2, which is 1/2. So that's how we use our half-angle identities. If you're interested in learning how to derive them, you may check out the detailed explanation in our learning guide. That's it for now. See you in the next video lesson.